नमस्कार, स्वागत है आप सभी का PMeVIDYA चैनल में। आपके साथ मैं हूं मुक्ता कांडियाल और आप देख रहे हैं हमारा ये लाइव इंटरैक्टिव सेशन। और हम हाजिर हैं हमारी मैथमेटिक्स की इस क्लासरूम के साथ। और जो टॉपिक हम आज अपनी क्लासरूम में पढ़ने वाले हैं वो है सिंपल इक्वेशन पार्ट 2, यानी कि पार्ट 1 हम अपने सेशन में पहले भी कर चुके हैं। अगर आप देखना चाहते हैं तो हमारे NCERT ऑफिशियल जो हमारा यूट्यूब चैनल है आप उस पर जाकर देख सकते हैं। आज हम पढ़ने वाले हैं यहाँ पर पार्ट 2, और इसे पढ़ाने के लिए जो एक्सपर्ट आज हमारे साथ जुड़ी हुई हैं उनका परिचय मैं आपसे पहले करा देना चाहती हूँ। आज की हमारी एक्सपर्ट है मिस गुरप्रीत भटनागर। मैम इज मैथमेटिक्स रिसोर्स पर्सन फॉर CBSE। नमस्कार मैम, एंड अ वेरी वार्म वेलकम इन द सेशन।
Namaskar ma'am, thank you for having me. Good afternoon to all of you who are watching us.
Yeah, thank you so much ma'am. It's an honor for us to have you on board. Okay, so all the learners, I would like to inform that if you have any question, any queries related to today's session, you can call us on our number, that is 8800440559. You can also write to us at dth.class7@cit.nic.in. Apart from these two medium, there is one more medium through which you can connect with us, that is our YouTube channel, which is NCERT official. You can drop your queries, any comments, any question through live chat box option over there. So today's session is for class 7 student. That means you're watching this program on PMeVIDYA channel number 7, also live on our YouTube channel, that is NCERT official. So without any further delay, let's start today's session and directly head to Gurpreet ma'am. Ma'am, before starting part 2 of simple equation, I would like to request you to give a quick recap what all we cover in part 1 and what all then we are going to learn in part 2 today.
Most definitely, Mukta ma'am. How can a maths class start without a quick recap? So thank you for the opportunity. हम पिछली क्लास के अंदर कर चुके हैं इक्वेशंस का recap from class 6. तो हम क्या-क्या किए थे पिछली क्लास के अंदर? Better would be to watch a video as ma'am is suggesting. But a quick recap for that was, how is a variable different from a constant? And how do we make equations? That all was covered in the chapter algebra in class 6. So today is the class where we are going to embark on the new learning from class 7, how to set up a simple equation and then how to solve a simple equation. So today's session is going to be a fresh learning for all of us. So shall we start, ma'am?
Yes, Gurpreet ma'am, we can.
Okay, so I would like all of you to pay attention to the slides because a lot of things will be moving there, and if you have any question or any answer you want to give, then please don't hesitate to participate. We would actually love that. So setting up a simple equation. Let me not waste time because I have so much packed for you. So let's start building a simple equation. Now, how do we write an equation? We know what is a variable. We know how to write a constant. How is constant different from a variable? So here is a mathematical statement. Now, what is a statement? A sentence which has some mathematics going on in this. So let me read it out to you. 9 more than a number is 13. We can see it and perceive it as a puzzle also. Now, what is this statement made up of? So we are looking for a number which is 9 more than, and it is equal to 13. Now, how do we write an equation? Since we are looking for an unknown quantity which we represent with a variable, in this particular case it's the number that we are looking for. So let me place that number on the number line just to understand what's really going on. So there you go. We have placed a number x. Now, what is the statement saying? The statement is saying go 9 more than this number. So shall I go on the left hand side of the number line or shall I go on the right hand side of the number line? More means we are ascending. That means going towards the right hand side. So there you go. Let's take 9 steps towards the right hand side. Now, here comes the last information from the question. The number that you landed up has to be 13. Now, what you can see on your screen at the moment is that a mathematical statement has been converted to some understanding of it in the terms of number line. Can you think of an expression which can be representing this situation? Take a second. You have done that in class 6. In the chapter algebra, we did practice how to convert mathematical statements into equations. So yes, you're absolutely right. The answer is x plus 9 is equal to 13. Now what you have in front of you, x plus 9 is equal to 13. It has two sides to it. There is a left hand side. What is that? The left hand side of the expression. That is x plus 9. And then you have a right hand side. The right hand side of is equal to sign has an expression which is 13. When we have two sides equated to each other with an equal to sign in between, such expressions are called equations. That's how simple it is. Let's try one more. Now here is another one. 1 less than twice a number equals 12. Let's break it down. 1 less than twice a number equals 12. Okay, let me take you to the number line again. So if I say twice a number, we could write it as y plus y. But we also know that like terms can be added. So y plus y is 2y. Now the question is saying go 1 less than that. So how do we go 1 less than? We go towards the left hand side. That's where the numbers are reducing. And over there you will find the last information that it equals 12. So there you go. Another one converted on a number line. Can you think of an equation which can represent this situation? Don't take too long. You have been doing this in class 6. So yes, the answer is 2y minus 1 is equal to 12. The left hand side is 2y minus 1 and the right hand side is 12. And since both the expressions are equated to each other with an is equal to sign in between, this whole expression 2y minus 1 is equal to 12 is an equation. Right now we are just practicing or recalling how to write a simple equation. Alright, here is a situation now. We come across such situations in our real life. So here is a man and his daughter. Daughter's name is Rama. So the question is saying Rama's father is 54 years old. So there you go. I am writing information for you on the picture also. And then the question is saying he is who? The father. The father is 4 times older than 5 times Rama's age. Now, the question is not giving any information about Rama's age. So, things that we don't know, we refer to them as a variable because it can vary. Now, in this particular case, I am taking Rama's age as X years old. Now, let's pick up another very important information in the lines. It's saying the father is 4 times older than 5 times Rama's age. So, if Rama is X, how much is 5 times of that? Of course, 5x. And how much will be 4 years more than that? 5x plus 4. So, the question is saying that the father is 54 years old and in the second statement it's also saying that he is 5x plus 4 years old. How can a man be having 2 different ages at the same time? No, no. So, can we make an equation using the information that's on the screen? Take a second, but be quick. Yes, the answer is 5x plus 4 is equal to 54. Simple, done. So this is what we do when we are setting up a simple equation. Whatever is the unknown quantity, we take it as a variable and with the given information, we try to have 2 expressions equated to each other. Now, if I have an equation, there has to be an answer. Now, the question that we have on the slide, it's not asking any question at the moment. But what if I had asked you that find Rama's age? Of course, we'll have to find the value of x. Now, for that, today's session is very, very important. So, stay with us. Now, before I move on to how to solve and what are the techniques of solving mathematically any simple equation, there is something more I want to show to you. How to check whether a given value of variable is a solution of equation. Recall you have done this in class 6. We're just going to just quickly touch upon it and move on to the agenda of the day. So here I go. So in a basket, I am seeing 5 apples, okay, and here is a sack, bowl, बंधी हुई है, नहीं पता उसके अंदर क्या है. but I have placed a is equal to sign in between. So if I'm saying the content inside this sack is equal to the content in the basket, can you tell me how many apples are there in the body or the sack? Of course, you will say it's 5. That's so simple. Now, if I would have said instead of the sack there was a variable x, then of course x is equal to 5 is the answer, which here we are going to refer to as a solution. So x is equal to the number of apples in the basket is equal to 5. That's the solution. Now let's change the situation a little bit. I'm still keeping this slide, but in the rucksack we do have 5, but by the side I'm giving you 2 more apples. Now does this equality make sense? The left hand side has 5 apples, and on the right hand side we have 2 apples outside and 5 apples inside the sack. No, that's going to be 7. How can 5 be equal to 7? So something is wrong. That means the equality does not hold. Now for this, basically what we are trying to say is that 5 cannot be the solution of this particular problem. Can you guess, or why don't you try telling me what should be the number of apples in the sack looking at the given information? Yes, the answer is 3. 3 apples inside the sack, 2 outside. The sum is 5, and that is equal to the number of apples in the basket on the left hand side. So in this particular case, the solution of this problem is 3. So don't forget the word that we have just added to our maths vocabulary, that is solution of a equation, of a simple equation. Let's move on to something we have done last year. Checking whether a given value of a variable is a solution of a given equation. Alright, so here is a solution, y is equal to 5. We have to check whether it is a solution of the given equation 2y minus 1 is equal to 12. For that, let's have a better understanding with a scale, the balancing scale as we know. So on the left side of the scale, I have put 2y minus 1. On the right hand side, I have put 12. So right now, the scale is well balanced. Now, what happens if I put 5 in place of 5? Is the balance still maintaining equality? Have a look at the left hand side and calculate it. Remember to use your BODMAS rule. Now 2 into 5 is 10. 10 minus 1 is 9. 9 is not equal to 12. So looking at this, we can say that left hand side is lesser than the right hand side. And hence we can say y is equal to 5 is not a solution of the given equation. It's that simple. Do you remember this now from class 6? I'm sure you do. Here is another one just for a practice. Is m is equal to minus 2 a solution of 15m plus 31 is equal to 1? Let's check quickly. There comes my balancing scale. On the left hand side 15m plus 31, right hand side 1. We need to see whether minus 2 placed in place of m still maintains the balance. Now let's try this. 15 into minus 2. Remember your integers. Positive into negative is negative. So minus 30. Now how much is minus 30 plus 31? Of course that is a 1. Now in this particular case we can say the left hand side and the right hand side are still maintaining balance. So what's the conclusion? Yes, absolutely right. Yes, you are right when you are saying m is equal to minus 2 is a solution of the given equation. This is how we check a given value of variable to be a solution of an equation or not. It is very, very important that we must check our answer. This is one way to check your answer for a question of simple equation. So let's move on. What are we going to do? We are going to solve a simple equation. Now let's have a seesaw. Why am I showing this to you? Wrong slide? Maybe. Here is my seesaw, which is mathematical. It has to be balancing its scale on both sides. So right now it's trying to find its center. And the minute it does, I can say the left hand side is equal to right hand side. What you see in front of you is a visual presentation of a simple equation. So whenever left hand side is equal to right hand side with an unknown quantity in it, must be there in one side or the other, has to be called a equation. Now, what if I have placed a sack, there you go, the same sack has come in, plus 3 is equal to 23. Now, can we find what is the value of this sack? Now, this plus 3, if I would have removed, because I need to find the value of the sacks, if I would remove this, what's going to happen to the scale? Of course, the scale is going to lose its balance, and now both the sides are not equal, so we need to do something better. That's what we are here for today. So, question number 1. Value of sack plus 3 is equal to 23. Is there a way I can remove plus 3 from the left hand side? Yes, we know our integers. So, what if I put a minus 3 on that side? The additive inverse of plus 3? All I have to do is just change the sign of the number. So, if the number is positive, we are going to write it with a minus sign. But we can't do that on one side because again the scale will topple over or it will lose its balance. So there you go. I'm going to place minus 3 on both sides. Can you see that? Now what's going to happen on the left hand side? Plus 3 minus 3. Whenever we are going to put plus 3 and minus 3, the answer is a 0. So magic happened on the left hand side. By subtracting 3 from both sides, I could get rid of plus 3 from the left hand side. Now, we need to take care of the right hand side also. We know how much is 23 minus 3. Are you saying 20? Absolutely right. The scale is still maintaining its balance. So now I can say the value of the sack is 20. Or maybe next time the sack is replaced by a mouse. How about a person waiting for 20 hours? But how about keeping it simple and using x instead of the unknown quantity? So for the moment, the slide says x value is equal to 20. In this activity, we learned that if we subtract the same non-zero number, now think about it, why a non-zero? Will adding or subtracting a 0 from both sides really make any effect? No, 0 has no value to it. So, we are only going to subtract the non-zero numbers that you know till now. What kind of numbers do you know? You know fractions, you know decimals, you know integers now. You also know rational numbers, positive and negative. So, I can add a non-zero number or subtract non-zero number from both sides. So for this slide, we subtracted 3 from both sides. I hope it is clear. Now let's move on to the solution. So if x plus 3 was 23, what is the solution? Of course 20, because 20 plus 3 is 23. There you go. Done. Here is second question. The sack with a minus 15 is equal to 2. Now, enough about that sack. Let's replace it with the x. From here onward, it's only going to be x. So the screen is saying x minus 15 is equal to 2. Now, let's try to get rid of this minus 15. How do I do that? A negative quantity can be reduced to 0 if we just bring its additive inverse. What's the additive inverse of minus 15? Of course, before I do that, I have to know if I remove any number from any side, the scale will lose its balance. So coming back to the question, if I want to get rid of minus 15, I can't simply just remove it. I have to keep the balance of the scale. So I add 15 on both sides. The balance stays. If we add the same non-zero number on both sides, the equality holds. So So whatever operation you do, the same operation with the same non-zero quantity has to be done on both sides. Now we know how much is 15 minus 15, of course that's a 0. So the magic happened, or meta magic happened. But we must take care of the right hand side also. How much is 15 plus 2? Of course, you're right, it's 17. And there you go. You made the math magic happen, and the value of x is 17. And in other words, in mathematical words, I could say for the equation x minus 15 is equal to 2, the solution is x is equal to 17. Now let's move on to one more. Equation number 3, I have x minus 1 is equal to 5. Now we know how to do that. Let's do something more. Let me just add another x to this. Now, this does not make sense. We know our algebra. Whenever we have like terms, we are supposed to compulsorily add. So x plus x is our 2x. So there you go. The equation is 2x minus 1 is equal to 5. That's our question number 3. Now how do we do questions like that? Before you touch the variable, or before you want to find the variable's value, get rid of the constants from the side where the variable is. So that means minus 1 must be removed. Now how do we do that? Of course, we add 1 on both sides. And the minute we do that, the left hand side, the constant goes away, and the right hand side is our 6. Now, the job is not all done at the moment. We have 2x is equal to 6. Now, how do I find the value of x? Only x. Let's split up this 2x again into this original form, x and x. And let me also split 6 into 2 equal halves. What is that? 3 plus 3. 6 can be divided into 2 equal parts as 3 plus 3. Simple. So on the left hand side I have x and a x 2 blocks. Right hand side I have 3 and a 3 2 blocks. If I just remove one x from the left hand side and one 3 from the right hand side, there you go. The value of x is 3. But this is fun only when we know how many parts we can make and what if the number is very large. Is there a better way to do this? Yes, of course. This is the rule. So if you have 2x is equal to 6, what is the coefficient of x? Or may I say, what is the number multiplied to the variable x? You would say 2. Divide both the sides by the same constant. That means divide the left side by 2 and divide the right side by 2. So this is our rule number 3. We can divide both the sides by the same non-zero number. Of course, we can't divide by 0. Think again, why can't we divide by 0? Maybe you should write to us about that. Why can't we divide both sides by 0? But for the moment, 2x divided by 2 is definitely an x, and 6 divided by 2 is a 3. I'm sorry. The solution of this question is x is equal to 3. Ma'am, I'll just take a second.
Sure, ma'am. And meanwhile, I would like to inform you, ma'am, that we have number of students who have joined with us throughout this session. They are connected live with us. And before you answered the question that the value of x is equal to 3, we already had the answers as 3 in our live chat box of our YouTube channel, that is NCERT Official. So that itself indicates that how informative and how useful your session is to all our students, ma'am.
Thank you so much. Thank you so much for joining us. It's wonderful to have listeners and people who like to participate. Otherwise, the sessions can be boring. So thank you for staying. So stay till the end.
Yeah.
So with your permission, may I continue, ma'am?
Yeah, ma'am. And we are only left with last 2 minutes of the session. So yeah.
Okay. I'll just quickly wrap it up. That brings me to another question. Question number 4. This is a simple one. 4x divided by is equal to minus 2. So what is the number multiplied to x4? So that's our hint. We are going to divide left side by 4. We are going to divide right hand side by 4. And the left side gives us x and the right side is minus 2 by 4. Do we leave our answers like that? No. We reduce them to their lowest terms, or as we call it, standard form. So x is minus 1 by 2. So the solution of the question is x is equal to minus 1 by 2. That brings me to the last rule. Now, in this question, you can see the equation is x on 2, that's half a circle, if I may say that, plus 3 is equal to 43. How do we solve it? Get rid of plus 3. First of all, the constants must be killed from the side where the variable is. So, there will be minus 3 on both sides, and when I do that, minus 3 plus 3 goes away, and on the right hand side 43 minus 3 is a 40. Now here I have x plus 2 is equal to 40. We are supposed to find x is equal to what value? I could simply just put another half x plus 2, but I can't do that just to one side. I will have to also put the value of that on the other side. So I'm sure you can make sense of that. If I have x plus 2 written twice on both sides, on the left side is x plus 2 plus x plus 2. What is that? That's an x. And how much is 40 plus 40? That's of course 80. So this question answer is x is equal to 80. But this is just a fun way to do this. What is the mathematical way to do this? If you have
Ma'am, I think with this question we can leave students with this question as homework, and we can just wrap up, wind up this session right now because we are bound by the time. Thank you so much one more time, Ms. Gurpreet, for having for joining with us for this wonderful session and delivering this informative session of simple equation part 2 to all our students. Thank you so much, Gurpreet ma'am. And I would like to thank all our learners, all our viewers as well who got connected with us throughout this session. For now, we are wrapping up this session, but we'll be back with another session that is of Urdu. Stay connected to PMeVIDYA channel and NCERT official. Namaskar.